Okay, so we will continue from where did we left last time. So we mentioned that in the fourth extended file systems, we have four important area: the boot block, the super block, the inode, the available block. The available block is the data block, where the data, actual information. Inode is more towards the addresses. A super block more towards the geometry of the hard disk drive. A boot block contains the bootstrap. Let's go to each one and explain it in details. Okay, so before moving, we need to ensure one important information, that the size for each block, like each block has a minimum of 512 bytes. So as you can see here, we have multiple blocks, right? We have a lot. So each block has a minimum of 512. It might be more. Yes, it might be more, but 1024. It might be 4096 and many other things, right? We can configure this. But the point is that the minimum is 512, but the normal or the average or the most common is actually 4096. Okay, so the first thing here is that the boot block. What is the boot block? The boot block, as you can see, contains the bootstrap code. So where can we load the operating system from? This information exists in the boot block. The bootstrap is actually exists in the boot block. So Unix and Linux computer has only one boot block located on the main hard disk, and it is actually block 0. So block 0 contains the boot block. Okay, so for the super block, what is super block? Super blocks contains the geometry of the data. So super blocks, it specifies the disk's geometry and available space. So it will tell us how many heads, cylinders, and sectors exist on this hard disk drive. It will also tell us more information about the block size. We do know that the block size, the minimum is 512, but it can be larger. Where can we specify this? Who would configure this? It's actually the super block. The super blocks will tell us the block size. The file system names. Do we have actually, what is the file systems, what is the actual file system? What is the actually block reserved for the inodes? We do know here there are several inodes. What are the blocks reserved for the inodes? Who defined this? The super block. Super block is like the manager of the all of every single thing. So the blocks reserved for the inodes and any volume name. So it's kind of blocks reserved for it's kind of managing the whole structure of the hard disk drive based on the extension or the fourth extended file system. After the super block, we have more important information. We have something called the metadata, okay? But we will not call it metadata. The fourth extended does not call it metadata. It calls it index node, information node, which means metadata informations about files and directory. Do you remember in Windows file systems, if we have FAT, if we have NTFS and there is NFT record, we have several attributes. We have attributes, for example, 20, 30, 40, 50. All of these are metadata about the data, but the actual data is stored in attribute 80, right? The same thing applies here in the fourth extended. In the fourth extended file system, it says that, okay, the inodes store all the metadata, but the actual data will be exist in the last block, the data block. So analogs to the FAT, file allocation table systems, and the MS-DOS, or similar to, for example, similar of attribute 20, 30, 40, 50, and the NFT record in Windows NTFS. So there are several information here. It says that actually it is the first data after the super block, because after the boot block, the super block, we have the inode block. So it's the first data after the super block and assigned to every file allocation unit. So any file, any folder, anything has an inode, inode is kind of addressing. It has an address, okay? We will see this together. So in order to see any inode here, I will go here, for example. Try to delete everything to make it better. Fresh. Yeah, well, okay. I think now it becomes يعني move to trash. Okay. I'll maximize the size of the machine. Now you can see better. Okay. Okay. So in order to see, for example, now, where am I? I'm the Kali. So LSCD desktop. Then I will say LS. Oh, there are a lot of things. A lot of things. I don't know. I would like to clear my desktop to make it simpler. Anyways, that's clear already. Okay, so if I say ls and then hyphen I, it will show me all the files here and its inode. So, okay, sorry. Let's go here. Okay. So what I will be able to see here is that, yeah. So I will see here my file, it has this inode, this file, it has this inode, this file, it has this inode. So let me go to another simpler one. So cd hyphen ls. So let me go to, for example, cd home. I have these, right? So I can say ls then hyphen I. It will show me that Hood has this inode, guest has this inode, Hind has this inode, etc. So here are the actual inode for each file or each directory. So it's therefore, like I can say that inode is assigned to every file allocation unit. What's the data block? The data block is the actual data. So where the directories and the files are stored and the location is linked directly to inode. So the actual data, we will see it in the data block. Now, the point is that we need to ask ourselves, what is the size of the block in the fourth extended file system? The minimum is 512, but the normal, the average thing is actually 4 kilobyte, which means 4 multiplied by 1024, or 8 multiplied by 512 blocks. So we have 8 blocks of 500, 8 blocks of 512. So if I have 8 blocks of 512, it will be 8 multiplied by 512. It will be 1024 bytes. So the normal size is 100, is the 4096 bytes. This means that the space used for a file in fourth extended must be an integer of multiple 8 blocks. And so 8 blocks of 512. So the smallest size used by any file less than or equal to 4096 bytes, this is it. So usually the normal thing is 4 kilobyte, which means 4 multiplied by 112, 124, which means 4096 actually byte. How can I know this? I can know this by using cat etc make extended to file system configuration. So if I type this, let me type it let me type here, cat etc mk, and then hit enter. It will tell me that, okay, for this, we have the block size is actually 4096. So this is the information. And it will tell you information about the inode size, other features, what are the file system types there. We have the third extended file systems, which is that has journaling. We have fourth extended. These are different file systems that we can format any file with it. But in our system, the default thing utilizer is like 4096 block size. As you can see here, when I type the same command, I have block size 4096. Okay, so inode contains file and directory metadata. It does not contain the data. The data is left for the data block, but the inode, the index node, the information node contains the metadata. Okay, an assigned inode contains the following: mode and type of file or directory. It will tell me whether the inode has information about, okay, is this a file? Is this a directory? It will tell me the type of it. How many links point to this file? Sometimes one file or one directory has more than one link, which means, okay, so I'll give you this example. Now we have one course, right? We have digital forensic techniques and tools, but this is given to batch to the fourth batch and the fifth batch, right? So the 4-year patch and the 5-year patch. So the 4th-year patch has different code than the 5-year batch. So we have different codes, which is CYS 302, CYS 404, but they refer to the same actual content, the same actual data. So I will tell that these codes are different number of links to the same content, to the same data. So this is what I mean. And how this is exists or related to the files or directory. This is related to the files and directory because sometimes we see the same file, but this file is shared by multiple users. So if it's shared by multiple users, by they say it have the same content, this means that multiple links refer to the same file directory. We call multiple hard link. Also, the inode store the user information, the group information or user ID, group ID of a file or directory, number of bytes in the file or directory, how many bytes are allocated, the size of this file, the size of this directory, file directory last access change, last access time, and last modified time, as we have it also in Windows. An assigned inode contains the following as well: inode last file status change time, when this file has been changed. So when the file permission or owner last changed. It also has something called direct, double indirect, triple indirect blocks, addresses for the file data. So when I ask you this question, how many type of inode do we have within the fourth extended? You will answer, we have actually 4 types. What are these 4 types? I will go to the slide 28 and then go back to slide 27. So let's go back to this slide. Okay, this is slide actually because this is a visual one. So actually we have here in the inode, we have 13 pointers that stores information about files, not the data. Okay, from pointer 1 till pointer 10, it has direct access to data. So pointer 1 access a block data. Inode pointer 2 access block data. Inode pointer 3 access a block data here. So they are direct access to data. Till 10, till access block 10. So this is, so we have actually the boot block, the super block, then the inode. This is the inode. We have only 13 inode. But after the inode, we have multiple inodes, and the green one is the data. Okay? So actually, the first 10 points to actual data, but 11 point to have indirect pointer, which means that it points to pointers. This pointer points to a data. 12 pointer, the 12th pointer has double indirect pointers. Double indirect pointer. What is double indirect? Actually, the double indirect means that a 12 pointer points to a block that contains 100 actually 28, and this 128 pointer each lead to another 128 more pointers. So this inode point to 128 pointer, and this 128 pointer points to 128 pointers, and this and together they point to blocks or data blocks. Okay, and we have this because this supports very large files. And the 13 pointers, this is the triple indirect pointers, which means actually we have 3 pointers in the middle. This is the first pointers, the second pointers, and that is the third pointer, and then the data. Okay, so 13 pointer is the triple indirect. Triple indirect means 1, 2, 3 layer of pointers. 12 is like the double indirect, which means 2 indirect pointers in the middle, 1 and 2, and then the data. Okay, so this is, I think now we get more to know that we have direct, indirect, double indirect, and the triple indirect. Now, if I go to the direct, we have data from block 1 till block 10. How can I know the data block after that? It will be usually 11, right? Because after 10 is 11. So we will see 11 here. But it will end to what? I will add to 10. I will add to 10. I will add to 20, 128. So 10 plus 128, it will be 138. So usually, to make it simpler, so let me type this. So we have here 1 till 10. And in order to know the start, I have to go to the last one and plus 1 to it. So 10 plus 1, it will be 11. So here's 11. And then how can I know the start of this? In order to know the start of this, I have take the last one here, which is 138, and I will add 1 to it. 138 plus 1, it will be actually 139. It will be here. How can I know the first starting data here? I need to say, okay, I will take the last thing, which is this, so which is 128 to the power of 2, okay, to the power of 2, to the power of 2 plus 1, and it will be the starting point of this. Okay, okay. How do I know the end of each one? In order to know the end of each one, I will say, okay, here is 10. 10 plus 120, I will get 138. Okay, 138. So, and then I will 138. And then in order to know the end of this, okay, 10, 138. I will take, because this is a double pointer, I will say 128 to the power of 2, okay? And this is because it is a triple, I will say 138, yeah, 138 to the power of 3, actually. So we can like know the ends of each pointer, the beginning and the end. Now let's go back to this. Okay, we stopped till here. Indirect, double indirect blocks, addresses for the file systems. So number of actual block assigned to the file. How many block assigned to a specific file? This is indicated by the inode. Okay. File generation number or version number starts in the inode. The continuation inode link is also, these are different information starts in the inode. The only piece of metadata is not in the inode are the file name. So the file name is not stored actually in the inode, it's stored in the data itself. Sorry, since it will be stored separately along with the inode number. So next to the inode number is actually the file name, and the content of it is the metadata. So the inode number plus the file name contains what? All the metadata. The inode does not store the actual data, as I mentioned. So here the explanation of the visual in slide 29. So an assigned inode has 13 pointers. Pointer 1 till 10 has directly access to the data storage, okay, block, and contains block addresses indicating where data is stored on that disk. So pointer from 1 till 10, direct pointer to the data storage blocks. But from 11 is the indirect pointer. Pointer 12, double indirect, and pointer 13 is the triple indirect pointers. Okay. Now we will tell something that sometimes we have some bad sectors. So sometimes it shows that disks have more storage capacity than the manufacturer states. So sometimes we have 2040 gigabytes, but it's actually 2040.5 gigabyte, but this 0.5 is actually a bad block. Therefore, it will not be shown. So the manufacturer show only the clear one, the actual capacity that will be presented, but this disks might have more than that. Windows does not keep track of bad sectors, but actually Linux does that. So we have here several things. We can utilize several commands in order to check the bad sector and the fourth extended file system. First of all, we can actually list all the storage medium. To list all the storage medium, I have to use list block, LSBLK. LS block means list all the blocks or list all the um, storage medium. So we have here hard disk drive, and it has several partition, STA1, STA2, STA3, STA4. And then I can run several commands to check the bad sector of each partition. So I will show you here, I will explain this slide and then go to the practical thing. Also, to find bad blocks, I can use either bad block command or make to fs or e to fs check. So the bad block, I can use sudo bad blocks, then hyphen v. Hyphen v means run it in a read-only mode. Don't do any overwrite. Okay, it's not recommended to utilize it. It's recommended to use the hyphen w. Okay, so if I type this bad block hyphen v, which means run this command in a safe read-only mode, it will checking for blocks, have those blocks, but checking for bad blocks, we have done, and there is actually 0 bad block found. If I type make to file systems, this means make extended to file systems, which means it is utilized for formatting sometimes. So I can type make to file systems hyphen C. Hyphen C means a scan during formatting. And then I will type, please format this text with this file system, because I can't format any disk with fourth extended, third extended, second extended, with any file system. So format and then check, and then will give me the results. This is actually a very destructive, not recommended command to write it. Why? Because it does the formatting, and formatting might erase data, because I might change format from, for example, from third extended to the fourth extended, and this would result in deleting some data. So it's not recommended. We have also E to extended to file system check, and then it will give me the results. Let's see this in practice. So Kali and Kali. And I will, for example, yeah, I will type LSBLK. It will tell me, okay, you have this storage medium and this storage medium. This is a ROM, but actually it is 124 megabyte, and this is has 20 gigabytes. But it is actually divided into several partition. The SDA1 partition, SDA2 partition, SDA3 partition, SDA4 partition. So when I do the bad block check, I will do it over partitions. So for example, I will say here, I will type, yeah, sudo bad blocks hyphen v, and then I will check on SDA1, which is this one. It is 16 megabytes, so it would be easy. But if I go, this would be easy, but this will take long time. This might take a better long time, but this would take very long time. It takes a lot of things. So I will check the SDA1. It will says that okay, I have checked it and it is done. There is actually zero bad blocks. So let's go to another one. So let's say I would like, for example, to check SDA2. It says completed, checking for bad blocks, and zero bad blocks found. Okay, so we can apply okay. I can also check the 3, but 3 will take long time. So why? Because as you have seen, and this contains actually 18 gigabytes. So checking bad blocks within 18 gigabytes is very, very long. So ls sudo ls block. This is very long. That's why it takes a long time. If I say sudo bad blocks but SDA4, this will not take that long time. It says zero bad block. Zero bad blocks here. Okay. So I can also use another thing. I will use make to fs and then hyphen c. If I type hyphen t, this might be very not safe command. And then dev, then I can say SDA1. But in order to make it not harmful, I can remove this part and keep it just check without any formatting. It will do the checking. Permission denied. Okay, so I have to choose sudo. Done. Super block creating file systems with this. File systems, super block, checking for bad blocks, read only done, allocating group table. So it checks for the bad blocks and it it checks and it will not say it. It's kind of creating a new things, but it checks and يعني for the bad blocks while we are formatting the thing. Okay, I will not run that last one. But it is not not destructive. We can also use hyphen C for checking for the bad blocks option with the file system or with the partition. Now we will talk about something called hard link. What does hard link means? What does hard link mean? Now hard link in a simpler way, two different files, two different codes, two different entities refer to the same file. So when I say ln, then file1 and hard link text. This means that both of them share the same hard link, which means they share the same address, they share the same content, they share the same thing. If I type ls-l and please list everything, I will see that the hard link and the file, they are actually, they are different files, but they have the same inode. See, this is the file and this is a hard link to text, and they have the same inode. What does actually hard link? Hard link means pointer that allows accessing the same file by different file names. Origin hard link were used so that people with different logins could access the same physical file. I'll show you here in this example. If one person changed a file, the changes would be apparent when another user opened the file. It's kind of a shared folder accessed by different users. So it's kind of like I have users called John, user Diane, and Rory. Both of them have different file name, company.database, mydatafile.db, tracking.db. DB stands for database. So different file names, but they have the same inode, which means anyone change anything here will be reflected here, will be reflected here. So how can we make this? I can create something called I will say clear, and then ls pwd cd desktop, and then clear. I am in the desktop right now. I will list. There are a lot of things. Okay, so it's better to go to another directory, to ls cd home, ls cd cali, ls. I have this. I will go to the document cd documents. I am in the documents right now. If I type blessed, there's nothing. Let me create a file. I will create a file, touch file1.txt, and then file2.txt. And then I hit enter. When I say ls, it will show me this. Okay, ls-l, show me in details. It says, okay, you have file 1, you have file 2, and each file has one link pointing to this. Okay, now I will create something called ln, and then file1 dot text, file2 dot text, and then I hit enter. Actually, yeah, it will be failed because all of them are exist. So these are two different files. So I will say ln file1 dot text, and then file1, we'll call it copy dot text. Okay, now create another file similar to this file, and then I will hit enter. And then I will say ls-l. It will show me, okay, you have 3 files. You have file 1 copy, file 1 copy, file 2 copy. This one has one hard link, but file 1 and file 1 copy has 2 hard link. What does that mean? This means that they look like there are 2 entities, but it is kind of 2 links pointing to the same folder. 2 links pointing to the same folder. Previously, when I type file, it has 1 link. But now, because of the len command, and I create a copy of it, okay, and they share the same thing, it's kind of creating 2 links. So if I say ls-i, it will show me that file 1 copy and file 1 text, they share the same inode, but file 2 has different inode. So file 1 copy has an inode ends with 91, but file 2 ends with 92. So this has different inode. So to see files and their inode number, we can use ls-ia. What is -ia? -i for inode, -a for hidden. So it will show you several information. So if I type, to check the link count, I can type -l. So it will tell me that D after text has 2 links. Rami has 2 links. Test.python has 1 link. The same as I have shown you in the example. Now there are several important information. Okay. The first information is that directory has higher number of link count comparing to files. What does that mean? Usually, now I have a directory that has, this directory has, okay, so the link count for directories is higher than for the other file types. So if I have any files, it has 221, right? But documents in general number of links are higher than files. Why? Because every directory has a default hard link, okay? So if 2 files have the same, so what are these default things? I will, let's say that I create a new folder here, make dir, and then folder digital forensics, or I can say digital forensics director, okay, ls. So I have this ls hyphen I. It will show me all of these, including the folder. So ls hyphen I. Now let's go to like, so this file has 2 links. This file has 2 links. This file has 1 link. This folder has actually 2 links. When I go to this file or to this folder, ls or cd folder df, and then type lsl. Although I did not create any copy of this folder, I did not create any copy, right? But minimum, this folder has 2 links to it. So when I type ls-l, sorry, oh, or ls hyphen, yeah, I think A, because it showed the hiddens. You will see something hidden here. Therefore, folders usually has hidden things that makes their links more than any files. So we have this, which is an inode refer to the same folder. This is referred to the parent folder. So the link count for directories is higher than for other file type. If 2 files have the same inode number, the link count is 2. So I know that they have the same inode, file 1 and file, so file 1 and file 2. So file 1, sorry, and file 1 copy. They have the same inode, right? The same inode. If they have the same inode, this means the link count is 2. And if I create, the link count is 2. If I create another copy of that, the link count will be 3. If I create another one, it will be 4, and so forth. If one file is deleted, the link count dropped by 1. So let's think that here in this example, I drop this one. I go to here, and then I go to the documents, and then I dropped this one. Let's say I dropped this one, move to trash. Not only this, I will go to the trash, and then I will also, there is something empty trash. I will empty all the trash, empty trash. So I empty all the trash. So now, now I have file 1, file 2. There is no file copy, right? If I type ls, then hyphen, if one file deleted, the link count dropped by 1. So it was actually the file 1, it has 2 links, but now we will see 1 link. So file 1 has only 1 link. See? 1 link only. Previously, file 1 has actually 2 links. When the hard link count drop to 0, this means that the file is effectively deleted. If I delete everything, there is no hard link to it. And forensics tools are most forensics tools, however, can retrieve these files easily and utilizing these hard link. So actually, by default, the link counts. To see the content of a directory, we use the ls-a to show the hidden file. And this dot means the actual file, dot means the parent directory. Both dot and dot count as links. So most directory have minimum 2 hard links, as I showed you here. So do you remember when I create the folder df? Although the folder df, so cd folder df, it was actually cd folder df. It's actually there is no file in there, but when I say hyphen L or ls hyphen a, it will show me that there are actually 2 directories or 2 inodes in there. So both dot and dot count as links. So most directories have at least 2 hard links. Here you can see, how can I see all the hard links for every single thing? From these. Here are the counts. So we have here 2 hard links, 4 hard links, 2 hard links, 1 hard links, etc. Now we would like to compare between something called hard link and symbolic link. What is a symbolic link? Symbolic link in a small or in a simpler way, symbolic link is actually kind of a shortcut. A soft link, simple link. It's kind of a shortcut. If you pointer to other files like shortcut in Windows. So it's not a real file. You are not creating a real file. We are just directing to the same path and the same name. Usually, this symbolic link has its own inode. So in hard link, they have different inode, but in symbolic link, sorry, in the hard link, they have the same inode, but in the symbolic link, no, they have different actually inode. It has its own inode. And also it points to a file by path, not by inode. So actually you are pointing to, it has an inode on their own. So if I create any symbolic link, everyone has its own different inode, and they depend on their continued existing of the destination they are pointing to. So if the original one is deleted, the symbolic link will be affected. If the path has been changed, the symbolic link will be affected. If a name and path no longer exist, the symbolic link stop working. Unlike hard link, which points to their destination with an inode number, same inode number, symbolic link, no. They know each other from the destination, from the path, from the file name, not from the inode. So in short, a symbolic link is just a shortcut that points to a file by its path. If the file is moved or deleted, the link will be corrupted or break. So in this lecture, we have explained everything related to Linux, to Unix, Linux, and the different types of Linux distributions, Unix distributions. We focus extensively on the second, third, and the fourth extended file systems. And the fourth extended file systems, we explain that there are several file structure starting from the boot, the boot block, the other block related to the geometry, the inode, as well as the metadata. I hope everything is clear. If you have any question, you can reach me at any time during the office hours.